Okay, so we're gonna talk about the nature of roots. Yeah? So one, when you talk about roots, roots are more like solutions that we obtain, okay, after solving a quadratic equation, okay? And we know that from the quadratic formula, which is minus b plus minus square root of b squared minus 4ac over 2a. Our main interest is whatever is inside the square root sign, okay? So this combination of terms inside the square root sign is sometimes abbreviated as a delta, okay? And some people call it a discriminant, or we call it a determinant. So discriminant or determinant. So now there are conditions that we must look at before we decide what type of answers or what type of solutions we have. Remember, the solutions are what we are calling the roots. Now we have a number of categories under which we look at it, okay? So if our focus is the b squared minus 4ac, just as summarized here, if it happens that this discriminant of ours is negative, in other words, it's less than 0, okay? So we can say that the roots are non-real, okay? If they're non-real, they are imaginary. In other words, they don't exist, okay? And in most cases, when you talk about numbers that we come across during the school years, most of them are real numbers, okay? So anything that is a negative for the b squared minus 4 is to give us non-real roots. That's why in most cases, when you find the square root of a negative number, the calculator just gives you an error. All right, then if it so happens that this discriminant is greater or equal to 0, then we're gonna say that the roots are real, okay? Greater or equal to 0, but in most cases, we prefer the greater part. What am I doing, okay? So we're saying discriminant is greater than 0, then the roots are going to be real, just as you can see. Then if the discriminant is exactly 0, then we can say that the roots are equal. Equal simply means that the two answers are exactly the same. Two answers have the exact value, okay? So it's like x is equal to 5, and maybe the second value, x is equal to 5. So this kind of scenario, that's what we call discriminant being equal to 0. Then after knowing that the roots are real, this can still be broken down, just as we can see, as long as the discriminant is positive. There are two scenarios now, that if the roots are not equal, automatically they will be unequal, okay? Then under the unequal, we have two categories. We have what we call the perfect squares, and then we have any other numbers that are not perfect squares. So if the discriminant is equal to a perfect square, okay, perfect square, then we can say that these roots are also rational, okay? And then if it is any other number other than a perfect square, the roots will be irrational. So under our description of roots, we have non-real, okay? And then we have real, and then we have something like equal or unequal. Remember, non-real or real. Let me just stroke it in that sort of format. Okay, it can be non-real or real. It can be equal or unequal. And then the roots can be rational or irrational. So in other words, when you're describing, you must have at least 3 aspects or 3 characteristics. One, the real aspect of it, and then the equality aspect of it, and then lastly, the rationality aspect of it. Okay, let's see. Here we have an example. We have a question asking us to determine the nature of roots of x squared plus 4x plus a 6. So what we need to identify, this is a quadratic expression. So our a is a 1, our B is a 4, the C is a 6. Remember, we say the discriminant is B squared minus 4AC, okay? The determinant or the discriminant, that's what we are interested in. So let's try to do the substitution of these variable powers into this expression. So that's gonna be 4 squared minus 4 times 1 times a 6. So it's gonna be 16 minus, what is 6 times 4? That's gonna be a 24 now. That's going to be a 24. I hope what I'm doing is correct. Okay, so in this case, we're saying x squared plus 4x, so which is b squared, which is a 16, okay? And then 16 minus 4 times 8 times that minus 24, which gives us a negative 8. Okay. Now, if our answer is a negative 8 and the discriminant is negative, what this means is that the roots, okay, are just non-real. The roots are non-real. So for as long as the roots are non-real, we don't have to go on and give the other aspects, the last two aspects. The last two aspects are only gonna work for the real part. Okay, if the roots are real, then we can talk about the equality and then the rationality. If they're non-real, that is the end of it, okay? So that is what we get for that particular question in trying to get the nature of those roots. So if we were to draw, let's say, a graph of this, okay, you'll find that the graph is not gonna touch the x-axis. Okay, probably it will be hanging somewhere there, regardless of what shape it is. So it will be hanging. So when it's hanging, it's not touching the x-axis, the roots are non-real. Okay, then probably I can also go further and explain this equality. So if the roots are equal and you have a graph, the graph will be touching one point just like that. And then if they are unequal, you'll find that one is a negative 1, the other one is a positive 2, something of the sort. All right, then the next one, why is this? Okay, it's okay, no problem. Without solving the equation, determine the nature of roots. They don't want us to solve the equation. They just want us to get the nature. So let's get our A is a 1, the B is a negative 4, the C is a negative 7. So we know that B squared minus 4AC. So negative 4 but squared minus 4, the A is 1, the C is a negative 7. That's 16. What is 4 times 7? Last time I checked, it was a 28. Yeah, it is still a 28, okay? Still a 28, it's not gonna change. So 16 plus 28, what do we get? 16 plus 28, I'm getting 44. All right, so if 44 is our answer, remember, 44 is greater than 0, okay? So which means the roots are real, but this 44 is not a perfect square, okay? It's not a perfect square, so which means the roots are going to be irrational. And then this is not equal to 0, so which means the roots are going to be unequal. So just tell us the roots are real, irrational, and unequal. We need to see all these three aspects. And then you're good to go. Then the next part, given x is equal to 2 plus minus square root of this and that over 6. Now this whole thing is a duplicate of what we call the quadratic formula, okay? If it's a duplicate of the quadratic formula, what do they want us to do? For which values of p will the roots be non-real? So for roots to be non-real, remember what we said, that the discriminant must be less than 0. From this equation of ours, we know that this 3 minus 5p is our discriminant. Whatever is under the root sign becomes the discriminant. So 3 minus 5p is less than 0. Then let's solve this. Let's move the 3 that side. So negative 5p is less than negative 3. When you divide through by negative 5, remember we said the signs must change, the inequality symbols. So that's going to be p is greater than 3 over 5. And then we're done. So we found the value. So all numbers of p that are greater than 3 over 5, the roots are going to be non-real. All right, then question number 3. Question number 3. The roots of x squared plus bx minus p is equal to 0 are non-real. Okay, they'll only be non-real under this condition where p is less than negative 9 over 4. Can we determine the values of b? Let's see. So from here, this is the A is a 1, the B is a B, and then the C is P. Okay, so we're saying B squared minus 4AC. So we have a B squared minus 4, the A is a 1, and then the C is a negative P. Okay. So B squared plus, this is going to be 4P. Can have it that way. Then if I look at this, let me see. If I have P is less than negative 9 over 4, let me multiply through by 4. So 4P is less than negative 9. Let me play around with this. Let me move the 9 to that side. So it's a positive 9 plus 4P is less than 0. So they told us that the roots here are less than 0. Né? So let's keep the less than 0 there. So now we have this equation, and then we have that. So what we're going to do, let's just do the comparison. Because we have a 4P here, we also have a 4P here. So which means this 9 should be equivalent to the B squared. So we're going to say B squared is equal to 9. Then let's solve for B by finding the square root on either sides. So which means B should be a plus or a minus 3. So that is how I would have approached this kind of question. Is there any other question? Oops, yes, there's one more. Okay. Question 4, if x squared plus 4x plus 5 minus p squared is equal to 0, can we find the values of p so that the equation has non-real roots? So if you have an equation that has more than 3 terms, your focus has to be on identifying the A, the B, as well as the C. So our A is a 1, okay? Our B is going to be a 4, and then whatever is left will automatically become the C part, okay? Then they told us the roots must be non-real. So B squared minus 4AC should be less than 0. Write this condition, you'll get a mark at least for that. Then let's do the substitution. So that's going to be 4 squared minus 4 times 1 multiplied by 5 minus p squared. This should be less than 0. We open this up and simplify. So 16 minus 4 times 5 is going to be a 20, negative 4, and that's going to be plus 4p squared is less than 0. Can collect the like terms, this and that is going to be a negative 4 plus 4p squared is less than 0. So it's your choice how you're going to simplify this further, okay? If you want to use your factors, or if you want to use the quadratic or what, but factors would be much more easy in this case, okay? So let's factorize ours common, but we can divide through by 4 anyway, just to make life easy for us, né? So that we have p squared minus 1 is less than 0. Then our critical values, okay, p minus 1, p plus 1, or move the one that side, find the square root. Okay, so the critical values are basically 1 and negative 1. Now, since the p or the a value is positive, our answer must be negative 1 is less p is less 1. So p must be between these two numbers. Okay, so that is what the question wanted us to do. So I'll stop there with this aspect of a nature of roots. If you have any questions, you can even slot them under the comment section and see if we can help you out. Okay, thank you very much and all the best.